Today on Capechi's Corner, we're going to talk about inverse functions and relations. When we're looking at an inverse relation, we know that it's the set of ordered pairs obtained by exchanging the coordinates of each ordered pair. So the relations are inverse if and only if you can switch all of the elements. So for instance, my ordered pair 1, 5 becomes 5, 1, and the same thing for the other ordered pair. So A and B are inverse relations. When we move on to the inverse functions, we know that they're also related. So the inverse function of f of x is written like that. Okay, so what happens basically, and we're going to do some graphs in just a minute, is I know I have two functions that are inverses if f of 6 is equal to 2, and then the opposite or the inverse is true. I have something right there. Okay, so let's do some graphs. So the directions say to find the inverse of each function, graph the functions and its inverse. So the first thing I'm going to do is I'm going to take this given function, I'm going to rewrite it as it relates to x and y. So I'm just going to replace that f of x as y, and I graph that in the pink right here. Okay, now to work with the inverse, I'm going to exchange x and y. So I have x is equal to 2y minus 5. And now I have to get the y by itself. So I have 2y is equal to x plus 5. Divide everything by 2. And I have y is equal to 1/2 x plus 5 over 2. I'm going to replace that with my notation. And I have that equals 1/2 x plus 5 over 2. Now, there's two ways we can graph these. We can either use it slope-intercept form if it's convenient, or we can make a table. So this first function up here, that was nice and easy. So I just graphed it using slope-intercept form. This next part here, when I have the inverse, it's a little tricky because my y-intercept is 2.5. It's doable, but a little tricky. But here's the important part of the functions, right? We talked about that the ordered pairs, we're going to switch them. So here's one way why it might be easier to use a table. So when I make a table for my original function, I'm just exchanging my x and y's, right, for every single point. So I may make a table for my first function, and for my inverse, I just have to reverse it. I don't have to calculate it all again. So that might be a reason why you might want to use a table. Okay, let's take a look at number 2. Again, the first thing I'm going to do is I'm going to exchange the f of x for y. And here is my parabola. Parabola rates a quadratic, so I graphed it. And this time I graphed using a table. Now I have to go through and working with the inverse. So I'm going to exchange x and y. So x is equal to y squared plus 1. Bring that 1 to the other side. So I have y squared is equal to x minus 1. Square root of both sides. So I have y is equal to plus or minus the square root of x minus 1. Again, the last thing I had to do is change my notation, plus or minus the square root of x minus 1. Okay, now the graph that's going to be a little tricky, so we're going to use a table here. So again, what I did was I took each point or each ordered pair that I already did, and I just switched them, right? Replaced the x with y and vice versa. So I have a parabola that we worked with already. We have not done the graphing of square root yet in our course. So you can kind of see, I just use a table, applied the points. You can see it's almost like a sideways parabola, again, which we haven't done. Now, one thing, and then we're going to go back and look at the first graph we did. The relation and the inverse relation reflect across the line y is equal to x, which is what this yellow line is right here. That's y is equal to x. And you can see if I kind of folded them on top of it, there is a reflection piece there. The same thing holds true if it's just a line. So even though these lines cross right here, there is a reflection piece. I did that along the yellow line. Okay, you can see that there's a reflection there. Okay. All right, let's move on. And we have two functions, f and g, are inverse functions if and only if both of their compositions are the identity function. So they're inverses. If and only if, when I'm working with this composition, I get x as my answer. So this is really not anything to do with graphing. This is really more to do with the algebra part of this, okay? So I'm going to do f of g of x. So I'm going to start with my function there. So I'm going to rate it a 3. As soon as I get to an x, I'm going to write my function that I have for g of x. So I have 3 times 1/3 x minus 3. Then I need to go back and pull down that plus 9. So this gives me, if I distribute that 3, I get x minus 9 plus 9. Combine my like terms and I get x. I'll do the same thing with g of f of x. So I'm going to start with g, and I'll start writing the 1/3. As soon as I get to the x, I go to the other function, f of x, and I get 3x plus 9. Don't forget about the minus 3. And I have x plus 3 minus 3, and I get x. And again, we talked about that up here. If when I do this, I get x for both answers, then yes, they are inverses of one another. Okay, let's do the same thing. So I'm going to start here, and I have 4 f of g of x, then I have 2, then I have 2 root x. And I'm going to have to square that. So that gives me 4 times 2 squared is 4. The square root of x is x. I get that. So I get 16x. I already know I'm looking for a value of x, so I know this isn't going to work, but we're going to practice on this video. So g of f of x, I'll start with my 2, and then underneath I have 4x squared. So I have 2 times 2x, which gives me 4x. So either way, I'm not getting solution of x, so no, they are not inverses. Okay, great job today. Thanks for stopping by, and you have a great day.